All right, clap your hands once if you can hear my voice. Great. How did the warm-up go? Yay, nay, okay. All right, so we're all over the map, yeah? Let's go over it a bit. So the first thing it says for us to do is to create a person class. How did that go? Okay, so I'm getting thumbs up, right? So we just got to create a class. We say person, curly braces. First thing inside of a class is what? Constructor. This takes in 2 arguments, right? Name and age. Then we say this. What is this? What's it referring to? The instance. Yeah, thank you. Exactly. This dot name is the name. This dot age is the age. Okay, so that wasn't too bad, hopefully. Oops. So then the next goal is it says, next write a class called people that takes no arguments but initializes with an empty array. Okay, so let's start with that. So the first thing I need to do is create a class called people. And I don't need to extend because I'm not extending my person class. This is just its own separate class. It has a constructor, but it doesn't take any arguments, but it does say to initialize with an empty array. I'm going to go ahead and call this people because this is going to be a list of essentially of the people that come in. So I'm going to say this dot people, and I'm going to assign that to be an empty array. Still good so far? Cool. So then we go back up here and we say, okay, add to people the ability to add a person. Okay, so that sounds like a instance method, right? On an instance of people. So let's go ahead and write add person. This is going to take in a person, and I'm just going to add this to people. This dot people dot push person. Right? Doesn't need to return anything because it didn't specify that I have to return it. Let's try these out as we go along. So let's create a person. Let's say let Corey equal new person, and I'll say Corey age 100, and let's also create a John. Let John. I always like. Oh yeah, okay. Equal new person, John, age. What's your age that you want to go by, John? 7. 7? All right. Cool. And then we'll create our instance of our people. So we're going to say let people be a new people object. And then let's go ahead and add a person. So I'm going to say people.addPerson, pass in Corey, and I'll just console log people at the end of this. Okay. Well, you could do that. It's okay. I didn't put out specific specs, so there's definitely bound to be a few miscommunications, right? But yeah, it looks like I have an instance of people that has a people property and an array of persons. Okay, great. So knowing that works, let's also go ahead and add John. Just make sure I'm able to continue to push people. Okay. Next thing it asks for is the ability to delete a person by name. Okay. So I'm going to add a delete person. And this needs to take in some kind of argument. I know that because how else will I know which person to take in? So it specifically says delete a person by name. So I know this is going to take some name. What are some ways I might be able to delete something out of an array? Ashia? Pop? Okay, that I'd be, if something is as fortunate to be just the last element in the array, I could pop it, sure. Farah? Okay, so I could filter. Does filter mutate the array? No, right? Filter creates a copy. So I could do it, but I'd have to do some reassignment. That's okay. What's another way? Britt? Not on the array. Splice, right? I could also use splice. Does splice mutate? Yeah. What would I need to know in order to do splice? The index. I think I heard a few places. Yeah. For now, I'm just going to use filter because I think that will be easier. And I'll just say this dot people, and I'll reassign whatever I get back from here. So it is this dot people dot filter, and each one of these is going to be a person. And I want all the person dot name that does not equal the name that's passed in. Okay, so let's go ahead and try that. To test, we've added John. I'm going to then go ahead and remove John. So I'm going to say people dot delete person John. Oh, I think I actually capitalized that, right? So right now mine's like not too case sensitive. It's very case sensitive. Probably the better way to put that. When I log it, I should now only see that I'm in there. Great. Right, we can make this a little bit more robust by just saying dot to lowercase and dot to lowercase. That way, if I don't, I can pass it in any way that I want, and I'll still be able to remove John. It's working. Yeah, Ashia.
Can you just explain that line? What is the name where you put in a function for after you initialize?
Sure, it might be easier if I write it this way. So I'm taking the return value of filter. I'm calling filter on an array. Each one of these is a person object, so I know it has the name property because I wrote the person class, right? And I say person.name to lowercase, so I'm checking the lowercase of the name property of person, and I want all of the ones that are not equal to my name that gets passed in as an argument. That's a lowercase. Anything that is not, that comes through as true here, which would be anything that's not the name, will get added to a new array and returned from filter. I am reassigning my this.people to be that new array. All right, cool.
And what was the reason that was lowercase? Is that so you can put it in no matter what?
Yeah, so I did that just in case I'm not sure or I don't remember the capitalization pattern of the original object. So I'm still able to delete John all caps instead of, even though it's in the object itself, just a typical capitalization, titleized. So it just makes it a little bit more flexible. Okay, we've accomplished all of these. Okay, see the last person added to people. So the last person added to people, how might I do that? David? Sounds good. So David says, because you're pushing in each person, push adds to the array from the back. So I can know for sure that the last person that was added is going to be the last element in the array. So, okay, I'll say last person doesn't take an argument, and it will return this.people at the index of this.people.length -1. Don't you hate writing this.people.length -1 every time for arrays? I'm really spoiled from Ruby. Ruby, I would just do this.people, and I would do -1. It allows us to index backwards with negatives. Such a pretty language. Anyway, JavaScript, you just have to do it this way. So let's go ahead and check that out. So instead of deleting John this time, let's go ahead and say people.last person, and we can console log that. Oops. Freaks out. Unexpected identifier. Huh. What's wrong? Let's make sure. I didn't close this argument. So it's acting up. There we go. And the last person we saw was John. Just to make it more clear, I'll do this. That way when we run it, we can see last person. It is John. Okay, so that's working too, yeah? Any questions on why we did that? All right. So we got a couple more. Filter. A filter people younger than function that gives back a shortened array of people. So this doesn't say to mutate, right? Just to give back. What would be a good choice for that? Filter people younger than. What should be the overall approach? Use filter? I like that. Will filter give me the results I need to just strictly return it? Yes, right? Because I'm just trying to give back a certain array. So I'm going to say return this.people .filter, and each one of these is going to be a person, and I want the person .age greater than the age that is passed in. Right? Another way to write this would be to do the brackets. These types of things I generally use dot because they seem a little cleaner and I'm comfortable with both. But if you're a little uncertain, go with the brackets. Okay, let's try this. So I think John put his age at 7. So we can say people.filter people younger than 8. And we should only see, I should log this too.
Oh,
What's that?
it's only filter. You look at 39.
Nice. Good fitler. Super into getting fit, so it's creeping in. Nice catch for the feed. I'm still spelling filter wrong.
People younger
Yeah?
than
Oh, yeah, nice. So let's just see how it would be written. People.filter people younger than is not a function because I spelled fitler here. Great. So it filtered though, right? That's the key point. All right, last but not least, shortened array. Okay, add a function called sort by age that sorts the people. Check MDN. All right. So let's see what I'm asking us to do. Go to Google and I write sort MDN array.prototype.sort. Make it a little larger there. So, okay, how does this work? Well, we see that I can just do months.sort, and I'll get December, February, January, March. So I get alphabetical sorting. But I also see that when I try to do it with numbers, it freaks out because it puts a million, whatever that number is, before 21. I guess it's 100,000, yeah? Yeah. So we go, okay, what else? It says we can pass in a compare function. Maybe it will show some examples. Okay, that looks interesting. Right, so it can take a callback function that says it's looking at one element and another element and returns one element minus another element. And that's how we get our 1, 2, 3, 4, 5. So I don't want to get too deep in the sort. This is more like if you made it this far. So we go, okay, that sounds pretty good. We can do that. I'm supposed to sort by age. So I'm sorting by number. So let's go ahead and do that. And we'll say sort by age. Did anybody pick up whether or not sort mutates the array? Yeah. I wish. No, sort actually does mutate the array. So if I don't really want to mutate the array, I'm just going to make a duplicate real quick. I'm going to say let dup equal this dot people dot slice at 0. Right? This is just going to make a copy. And that way this one I can go ahead and sort without messing up my this dot people. Because I still want the other one, like last person in the array, to be added. I don't want to. If I have an array of 13 things and then I sort them by age, and then my last one isn't necessarily the last person added. So I'd have to come up with a new plan otherwise. All right, so I create a duplicate, and I'm going to say return this, dup.sort. This is going to take in a callback function that takes in 2 arguments. So I'll say person 1 and person 2. And I will just return person 1 dot age minus, right? Because person 1 is going to be that first element, so it does all the same properties, minus person 2 dot age. And let's try it. So we will console.log people dot sort by age, invoke, and we'll still console log our people underneath just to make sure it doesn't get changed. And we'll see that first one has John and then Corey, and the original still has Corey and then John. So it's working. Questions on any of that? Does it feel easier when we go through it?
Can I see that code for
Yep. Any other overall questions about this? Yeah, Shia.
So what is it called in this
It's looking at 2 objects at a time, or specifically 2 elements of the array, and it's doing a comparison. So our array is filled up with objects, specifically person objects. So person 1 is one object in there, person 2 is another person object, and so it's comparing their ages.
So if we have more than one, how are we going to compare?
Oh, because it's happening under the hood. Just like map, we're only passing in one element, and it still calls it for every element. This is calling it for multiple iterations. It's doing something a bit more complex under the hood. It's probably doing something called merge sort, which we'll learn later. Yeah.
The return is, so like person one in this case was Corey, 88 to 100.
Right.
And it's 100 minus 7, so it doesn't show.
So it's returning, our compare returns a positive, a 0, or a negative.
God, so because it returns a positive.
This one would, yeah, it would say that that one number is bigger. So it would get swapped. I don't want us to get too caught up in like the inner workings of sort. It's not that important at the moment. It's more of if you could blast out this kind of class, right? We're not going to ask you to sort something on the test because we haven't like gone over that in depth. You will be asked to create objects, right? This is built off of your game as well that you're creating. Hangman is all about objects. So is there any questions based off of looking at creating a class object and having them somewhat relate to each other and connect? So anything not about sorting? The sorting was a bonus. Most of us didn't get that far.
Or, the last person function?
Yep.
Yes. So when we call a function, we have to put it in brackets because it's an empty array.
Where are you talking about?
Line 23.
This is how we key into an array at a specified index. Right, we have an array, and then we key into it. Same way we key into objects, the keys of an array are the indices. And so the last element is the length minus 1.
And then for filter, we're only, when we invoke filter, we're only getting back what we're asking for.
We only get back the elements that had a truthy return value from the callback function. Kevin. Can you give me a line number? This one? How come I did? When did I do name and brackets? Where's name and brackets? Okay, what about it? Oh, really? Because of the dot lowercase?
No, I think it's the, you forgot to do the string.
I'm doing an error.
Because if you're going before this, if you're going to the.
Oops. Yeah, everything should be fine. Yeah, I guess you had made an error. All right. Good question. Any other questions? Yeah, Brandon. So person only has 2 properties, name and age. And I would create a new person the same way that I did on lines 37 and 38. I would key into those like this. You could say console.log Corey.age. That will give me 100. Let me just go ahead and comment these out so they don't also print. Thanks. And we get 100. So we just key into it like we key into any object. The person class has no other methods attached to it, has no instance methods. People has an instance methods. And so people, I had to create a new instance of. in order to call those methods on them, which is what we did in all of the tests.
So creating people, we're calling the methods on person.
Nope, person has no methods on it. It only has two properties, name and age. Right? We can look at the class. This is everything that a person has. This is everything people have. But people do have an array of person objects. Right? It's a separate object. Person still has its things, but people can hold multiple persons.
I just don't get why you have to call
Line what?
40 actually. I don't understand why you have to set a variable and let people.
Because I have to create an instance of people. Right? People itself looks like this. Good question. Let's do this. We'll say console.log. Oops. We pass in people. People looks like this. This is an instance of the class people. People has a lot of methods. It's handling persons. It's like, think about it as like an administration or like at a school, right? A class has lots of students, but it has to actually contain those student objects. So like a student has an age and a name and a grade, I guess, right? But then the class still has like the subject and has a roster of all of the students within that class. So this is the same thing. I named it people because it's literally holding persons, and multiple persons as people. Right? All of these things outside of the constructor are instance methods. If we want to make a method on a class, we have to use that static. But we don't tend to write static very often. You don't generally need it. We're mostly excited about creating methods on an instance. So I could have an entirely different people instance, right? This people could be like our class. I could call this 6-4 class, right? But then I could also have a let 6-2 class. I don't think I can really start these with a number, right? But we can do it like this. Class 6-4, class 6-2. And these are two different lists of people. So I can go ahead and add a person to my class. Call that class 6-4. Right? So John and Corey are in this class. But I can also add people. I can create new people. I can say let Alejo. And he's a new person. Alejandro. We'll say he's 40. Right, Alejandro, he belongs in class 6-2. So 6_2 dot add person Alejo. Right, so now we have two different instances. We've got these are like people are a list of persons. So we can say console.log class 6-2 and 6-4. So now we'll print these as two separate things. So we have one instance of people that has Alejandro on it, and we have another instance of people that has Corey and John.
So what would be a reason
What do you mean by that?
Like,
Well, you wouldn't usually console log. Well, I'm just console logging to demonstrate so you can visually see it. If I was building something like this for like an administration, right, you would have different students in different classes, and this would allow me to do something like that. I would also probably have something in the person that I could enroll them into certain classes as well, so that they'd be aligned. But then we're building out an entire administration platform. This is just a list, different lists of people. Right, we could call people family. I have a family, you have a family, they're different. Right, but so we would have them in different lists. New people. It's right, it is right here. People is the name of the object. All right, we got to move on. Let's do it. So, if you're still lost on that, like, flag me later, right? I'm more than happy to talk with you more about it. Yeah. Yes. Good question. Keep me sharp. Okay, so today we're going to learn a bit about constructor functions. Not sure how deep we'll go. As in, I don't know how deep I want to go into like prototypal inheritance and whatnot. But it's important to know the syntax of ES5 because there was a lot of it prior to ES6, right? So many things online. Probably even now when you're looking on ES5. Code wars and stuff too. So we're not going to do all of this in ES5, but we're going to do some of it. Okay? So the syntax for ES5 is as follows. Let's create a person. The way we do this is, what's the first way we create a function in ES5? Function. Okay, so that stays the same. We can file that away as something that's identical. Okay, and now we write the name of the function, which in this case is going to be like that class name. So JavaScript doesn't actually have classes. This is just something that was added to be like syntactic sugar. It actually has like lots of objects that are considered prototypes and whatnot. So other languages have classes. JavaScript kind of has classes by words, but it's still functional at the end of the day. Don't let that like really confuse you. Just understand that what we're writing today is the original way of writing it. What we've written before is just the syntactic sugar of everything we're writing today. Okay, so everything before is a lot prettier. Okay, so for this, we would write person. Again, this is proud camel case because it is you can class, yeah. What's the next thing that happens when you write functions? Parentheses, yeah. R's take in what? Name and an age. Curly braces. Now the only difference is before in our functions we would like return something and all that, right? And there's lowercase naming. This we just do something. This is the constructor function. So knowing that this is the constructor function, what do you think goes in here? Right, exactly. This dot name is equal to name. This dot age is equal to age. And that's it. No return, no methods. This is just setting up. This is the constructor function. So this refers to the instance that is created when we make a new one. So when we call this, we'll do it. We'll say let Corey, and it will be the same. It will be, bless you, new person Corey and 100, and we will console log the instance of our person, which is Corey. Let's just clear this out of the way. So it still works, right? It still looks the same. Everything is essentially the same.
So how do you do with the function size?
Ah, good question. So Kong says, how do we build the instance methods, right? So what about if I said something like this? What if I just did like this dot talk, and I said function, and I just added console log. This dot name is talking. Okay. So now I have talk pointing to this. So fly. I hope it catches my cold. Right, and I could also call Corey and have him talk here. I could say Corey.talk, and it works, right? What do we see that's different, though, than when we did it before? Okay?
The methods are no longer hidden.
Yeah, so Jay says the method's not hidden this way. The method is on the instance. Does anybody know why that might be a bad thing? What? Hard coding? Maybe, but that's not quite what I'm looking for. I like that though. Any other guesses? Okay?
If you would want to print the object, it'll show a bunch of methods, just pop functions.
So negative printing. Okay. Maybe. Kelvin?
So each instance will have all the functions for each time that you call it.
Yeah. That's totally right. That's exactly what I'm looking for, right? This is a huge hit on performance. So if we have a Corey, and we have a John, and we have a Celine, and we have Danielle, right? And we have a D. I'm not going to do your whole name right now. And we have a Kong, and we just keep going, right? All of these will have a name, which seems normal, right? But then it also has this talk. And it has this name, and this talk, and this name, and this talk, right, etc. And then if we had more functions, right, maybe I have a sleep, and a sleep, and a sleep, right, and we'll give an eat, and an eat, and an e, and you can have a lot of functions, right?
Yes.
Now, what are the unique aspects of these Of each person here, what's the only unique thing? Only the name is unique, right? So this is all redundant, right? This is all the same, like the same. So in order to create all of these on every instance, which you can, this will work. I could program an entire tic-tac-toe game like this, right? But every time I create something, I am creating all of those functions. And so this could be a performance hit. So instead of doing that, in JavaScript, we have something that is called the prototype of the object. You could think of this as, well, it is the prototype. In our class, we just didn't name it prototype, but we just called it like our class methods. You could think of that as the prototype. So instead of putting it here, we do this funny thing. We say the name of our class, person, dot prototype, dot the name of the function we want to write, so talk. And then we have to assign this. So I'm going to assign this to be a function. that goes ahead and just console logs. And I will say this.name. I'll be able to access through this.name. Is talking. So now we're going to run this code again. And we'll see that we still have Corey is talking. And our person still has the name and the age, but now we don't have this function that will lead to redundancy as we create more and more objects. Right? Redundancy hinders performance. You can think of it that way. So now it looks identical to our previous code, yeah? Not too killer, right? Right, yeah, this is just the syntax. So this is still called on the instance, right? Prototype methods are called on the instance. And the this refers to the instance. So just like if I was writing my own array.pop or something, let me go down to the bottom for this. Right, this is called monkey patching, is when I want to add new things to existing classes. So I could say like array dot my slice. Okay, actually I need to do array dot prototype, right? Dot my slice. So this is kind of replicating the slice. This is going to be some function that takes in start index. Mine's going to also just take in an end index, for sure. I could really write the real thing with defaults and stuff, but I don't want this to be complicated, like at all. So just do this, and now inside of here, first thing I'm going to do is console.log this, just so we can see what this is. Yeah? Thank you. Yeah, so it really helps to be able to spell. Okay, so we'll say 1, 2, 3, 5. So I'm going to say array dot my slice. What do we expect to see printed to the screen? Repeat. All of the numbers of the array, individually or as what?
Just in, like, as it is. With the comment.
As it is. Okay. Agree, disagree? Team agree? All right, there's a lot of people who disagree then. What else are we thinking? What are our other options? Isaiah. Well, yeah, I could pass an argument. That's going to be irrelevant. JavaScript will do whatever it wants. I'm not using the arguments in here right now. Shit. Maybe it'll only give me back a few numbers. Okay. So, prototype methods are called on what? On the why are we whispering it? On the instance. Excellent. Right? Say it loud and proud. If you get it wrong, like, so what? Right? Don't make me go like hard of hearing here. It sounds like I'm hearing voices in my head. They're like, some of them are whispering instance, some of them are whispering something else. I gotta be able to sort out which ones are the real voices and which ones are yours, right? Humor me. Okay. So if we call prototype methods on the instance, and we said that this represents the instance, the word this, because we were able to do this.name a minute ago, what's our array.slice going to print? Our array, right? 1, 2, 3, 4, 5, because we're calling the instance is the array, right? So if I wanted to just do like a quick little my slice, I would have an output, right? It'd just be an empty array, and then I would do for let I equal start index, right? And I would say like while I is less than end index, I plus plus, I would just output that push, whatever, right? This at I, because this is the array. And then at the very end, I could just return my output. And then down here, I can actually use this how I would generally use a slice. Or I could say from 1 to 3. So I would just get 2 and 3. And we get it, right? This is just like a simple slice. Just where we're going from one index to the end index. Right, I could add a default here. I could say like default this to this dot length. Now I could not write a 3, and I'm getting closer to the real slice now, right? Right, but the point of that is not that I can write slice quickly. The point is that this is the instance and represents the instance. The word this. It's a key word. It's a weird word because you have to say like this is this, right? In Ruby, it's called self, and in a lot of languages, it can be self too. So sometimes you'll see people, if they want to keep track of this in a new scope, they'll assign like self to this or that to this. I'll show you what I mean later. Okay, so that's our silly slice. So what's the main thing we haven't talked about yet that we know from the other thing? From our classes. What's the one thing left? Jay says extends, right? So we had a way to extend a class before, and right now we don't. So this is where the syntactic sugar of the ES6 really is just awesome. So in JavaScript, in order to do this, let me see if I can look it up and remember. Let's create a teacher instance or a teacher object, right? And I can say function teacher. And for this, I'll say name, age, and I'll say subject. And just like before, we used to call super, right? So this one's a little different. This one I call the class that I want, like this. I say person.call, and I have to pass in this. Is that right? I don't know. We'll see in a second. Name and age. And then I'll do this dot subject equals subject. All right, so nothing too different. It's just a little weird. Let's try it. Let's create a teacher instead. So, hey, I'm a teacher. I teach JavaScript. Let's hang off on the Corey.talk, and let's go ahead and print, and we see I still get name, age, and subject. So I'm still getting this instance, yeah? Do we think we have access to talk still? What do we think? like hearing no? Why? Because this hasn't extended. It's not on the prototype. Henry,
I think you can.
you think I can?
Yeah.
All right, let's take a poll. Team I can. Team I can't. Okay, we're like relatively split. Let's check it out. Dun-dun-dun-dun. We can. Right? It's gonna freak out. Query.talk is not a function. So inheritance in ES5 is not quite as slick as ES6, right? I'm able to inherit with that instructor pretty easily, but I'm not quite done yet. So if I want to, I have to do a couple more things. I have to say teacher.prototype, and I create a new object that will take in the place that I want to inherit. So I'd say object.create. I got to spell that right. And I want my prototype for my teacher to point to animal. Oh, not animal. I'm looking at an example of something. Person. I don't write in ES5 that much, right? I still need notes for this. Person.prototype. Teachers are animals, all right? I just forgot to write the animal class. How about now? Is it going to work now? Okay. Let's see. Okay, so now it works. What? So let's look at a couple things. Let's look at a couple more things. So let's go to Corey. Let's console.log. Console.log, and we will console.log our actual teacher to see what that does. I think it's just a function. Let's see what its prototype is. It is a person. Right? Our person doesn't really have much on it. But it doesn't have, to just compare something, instead of doing teacher, we'll do person. Right, our person had that talk function. And we can say that constructor. So we had as a constructor, it was a person. But if we do this for teacher, I think if I've got this correct, it's going to give us something else. It's now pointing to person. But what should our teacher's constructor point to? Right, so we have that constructor function that creates the new instance, right? Our person's prototype.constructor pointed to that person function, but now our teacher.prototype.constructor also points to that function person. So what should it point to? What's the constructor? Yeah? Should point to the teacher, right? Okay, so the way we can do that is by writing this little line. So we can say teacher dot prototype dot constructor. We can say that that is teacher. It's a little weird, but now we get that. So now we are done. Now we have done a successful inheritance. I'll move it up so that we can see all of it together. So if we want to inherit, we have to call person. We have to call the class we want to inherit from. We have to pass in this, as in this instance, and the other properties that we are inheriting. Then, at the end of that, we have to create our prototype of teacher to be that of a new object of our person, type prototype. And then from there, we have to reassign the prototype.constructor to be the same as our current class. There's an older trick that's called with surrogates, but I'm not going to get into that because I think it will just be more confusing than it needs to be. Sure. Hang on, I'm lost on my mouse. Yeah. All right, so this is how all the code used to be written. Cool. Nope. Well, you have to for today's lab, but that's only to just get used to seeing it a little bit. But after today, we can go back to classes. You should be familiar with prototypes and the idea of prototypal inheritance. Right? That's the idea of this. So I have a core instance. So I'm going to show you some stuff. I can do console.log query, and I have this underscore underscore proto underscore underscore. Right? This is not standard for all run engines. But if I do query.query, I can see, this is a different console log. Hang on. I don't want any other console logs right now. Let's actually, what's going on? Clear. We can see that we have this, the proto is of this instance of query. We can call this hidden property, underscore underscore proto underscore underscore, and it shows that we have this teacher and this constructor that points to our function and teacher. So if it's going to look on the instance for methods originally, and then it will expand out to this, right? Teacher has no other methods to it. We can go ahead and put one on if we wanted to, real quick. Just say like teacher dot greeting, or I'll say good morning because that's what I say. But we should have it say dot prototype. So easy to forget. Prototype dot good morning. It's a function that, how do I say good morning? How do I usually say it? Good morning. Yeah, that's right. I usually yell it. I just didn't today because of this cold. My energy is like a little lower, and I apologize for that. I don't know. Somebody got me sick. I don't know who it is. So I can look at all of this teacher class with that underscore underscore proto. I can say, oh, okay, this is like all the stuff that is on an instance. Like if I move up the chain, that is essentially going up the chain. So I could do it again. I could say underscore underscore proto dot underscore underscore proto. Oops. What's one above this one? What's the next one? Right? So we looked at the instance, we went up to the prototype, and we saw this. What's the next thing we go to? Who? What do you say?
Top.
Top. Oh, okay. Right, so you say we're going to be able to see top because the next proto is our person proto, yeah? Right, now we're in person. What's going to happen if I do it again? What's above person? Who's the king of all objects? Just object. Empty. Right? Nothing left. Okay? So this is what I mean when I'm saying, or when you hear, like traveling up the prototype, or prototype inheritance, or traveling up the prototype chain. It checks the instance. So let's create an instance. So we say, I'll draw on the board. So let's create a cat, right? We say we have this new cat. Right? This cat is, well, we can pass a name to it. I'll say Noboru. That's one of my cats. It means to ascend in Japanese. It's named after a book. Anyway, cat, this is the instance. This is a cat, an instance of the cat object, right? So if I say if we call a method on cat, what's the first place it's going to look for that method? The instance, right? So if I said cat dot name, right, it would look at this instance. If I said cat dot make noise or meow, let's say, it's going to look first here, but it might not find it on the instance, right, because it's not a direct property. So it goes and looks into this cat, which is like my cat class. Okay? Now if I did cat dot make noise, where's the first place it's going to look? Here, I'll change colors. Make noise. Where's the first place a method looks? The instance, right? So it's going to check this cat that I made here. Does it find make noise? No, because we only passed it over anyway. Then where's it going to look? It's going to go look at the cat, right? Okay, so it doesn't find it in cat because cat doesn't have a make noise because cats don't make any noise. So where does it look next? Hypothetically. The object, or if we inherited from cat, like some other cat, right? If we had animal. Then it's going to go ahead and look at animal. All right, so then what about if I wrote down here and I said cat dot toString. Where's the first place it's going to look? Henry? The instance, right? Cat dot toString on the instance. Is it on the instance? No. So where's it going to look next? Yeah, it's going to look at the prototype, right? This is the prototype. Okay, if it's not on cat, where is it going to look? It's going to move on to animal. If it's not an animal, it's going to look at object, which we couldn't see it there, but it will have a built-in toString. Everything that, like, you could write toString on anything because everything is coming from object. You can't on like a number or sort of. So numbers and strings are primitives, but they actually have a wrapping, and that's why we can write certain properties on them. I'm not going to go into that right now, but it's like a quirk, sort of. Okay, any questions on the ES5 version of how to create classes? Ashia?
I don't know where mine is, but in the function for teacher,
Yeah?
yes, mine 17, I don't understand person.call.
This is like us calling super before. Remember how we would say person, here, let me write the equivalent. remember we would say class teacher, and this doesn't take anything, sorry. And it takes in a constructor, and we would have it say name, age, subject, and then we would say, oh, sorry, teacher extends person, right? Extends person, I almost like, that's like the whole point. Person, and I did super, and I would say name and age. Just subject. Subject. This is the equivalent. So instead of saying extends person, I'm making a call to person. Call is a built-in JavaScript method. And you have to pass in this, as in this instance, this context, and then the name and the age. Since it's expecting name and age, and person is expecting name and age. Good question. Repeat.
Yeah, so for the ES5 version, you have to declare in the parentheses of this, and then you have to write again that this subject is subject.
Well, you have to do that anyway. ES5 and ES6. This that subject is not something we're inheriting because a person doesn't have a subject.
I see. Okay.
Good question. Next question. Yeah? Yes? Anything else? We're good? We're ready to hit the lab? Yeah? We're ready to rock and roll in the lab? All right, so I posted pairs. I was getting a lot of complaints that the pairs before didn't seem like randomly generated because there was a lot of repeats. I wrote my own random generator now, so these pairs are random. Okay, so I don't know what the old one was. Maybe it wasn't really random. Anyway, so you got your pairs, and I'll push this, and good luck.